for that, maybe I will give a few words about what my project is about, and also my background with respect to the project, such that hopefully I might give some ideas or some things to which you can relate. So indeed, the project is about twinning. So it's somehow linked to the idea of real-time modeling of systems, and in particular, systems that are, let's say, sufficiently similar, like think of clusters of wind turbines or drones or cryogenic tanks. And these are obviously selected test cases, test cases which were selected also because of their relevance in the energy transition. And somehow the goal of the project is to make these systems, if you want, smart, so able to self-learn and self-control. Now, the idea of reinforcement twinning, of retwist, is that you attach to each of these systems some sort of a unit, if you want, which we call the reinforcement twinning unit. And in this unit, you have two, let's say, modules or agents, if you want. One is a predictive agent that is trying always continuously to forecast the evolution of the system. And the other is a control agent that tries always to get the best out of it and to control it, let's say. Now, of course, there is a growing body of literature, mostly at the intersection of robotics and machine learning on these ideas, even though much of it has not yet reached energy engineering. And the project of this was, of course, first of all, to bridge this gap, to bring this idea into energy engineering and into mechanical systems, but at the same time also bring two main core innovations behind the traditional methods of adaptive control or even model-based reinforcement learning. And the first main idea was somehow is to combine an hybrid formalism. So there is a combination of physics methods and machine learning driven methods. And somehow these are used both for the predictive agent and for the control agent. And then the second idea, was probably the most important one, is to establish some algorithmic ways of linking the learning behavior of these two systems. So find ways in which they can help each other. That's what we call learning feedback. And also finding ways in which reinforcement twinning units of different systems can help each other. So that's why it was a key to have many systems which we can consider similar, such that somehow they can all learn from each other and they can all learn from their different experience, let's say. So the project is structured in 5 work packages. There is one main work package which is on the development of the algorithms. So this is the most, if you want, machine learning flavored work package. And then there are several work packages. Each of these dedicated to the test cases which I talked about, so wind turbines, drones, and cryogenic systems. These were chosen very carefully, not only because of the impact in energy transition, but also because they have different challenges, very complementary challenges in terms of dynamical scales, in terms of many technical things, let's say, from a control point of view. So the idea of having something that could be applied on very different fields, touching on very different communities, I think was also one of the strengths of the proposal. Now, to prepare for this, let's say over the year before my preparation of the ERC, I had already started working on this problem, somehow to build, if you want, credibility and to know, to have some proof of feasibility, if you want. And I would say these were, if you want, strong points. I already had a large team of students working on these problems, on these small setups. We started to build the first setups, the first prototype in this direction. So somehow we had enough expertise on these specific test cases. The novelty still was that these were not, at least initially, designed for twinning and for self-controlling purposes. They were most designed for us to learn about these systems somehow. And on the other hand, in my CV, I'm a mechanical engineer. I come more from an energy world, if you want. I did not have a strong background on the, let's say, the machine learning side, on the most algorithmic side. So I knew this was somehow a weak point, and to try to build the idea that let's say that the idea was still feasible, not too high risk. Together with the proposal, basically, I've been working also on 2 publications that could give somehow the proof of concept of the idea. And these publications were submitted basically together with the proposal. So at the moment of the revision, they were only on archive, on a public repository, but not already peer reviewed, let's say. And somehow these were really giving the very general idea, but the proof of concept about these learning feedbacks, no application on real systems. So everything was very conceptual. So that somehow we could say that there was an important intellectual gap before achieving the final goal, and that's why we needed that's why I needed the ERC, let's say. But somehow these ideas were more or less there, and I could somehow show that I was going in the right direction to reinforce my CV for this project. So my background, I defended my PhD thesis in 2018, and this was my first application, even though for several years I was somehow in my mind already preparing for it. So I had a strong background because of my PhD and because of my training on experimental testing and modeling, also a bit of data simulation. I had a proven track record, let's say, of experimental fluid mechanics and working with engineering systems. As I said, my background was not on machine learning, was not on computer science, so I knew that I had to really work hard in this direction. So over the years, I spent a lot of energy to grow my group in this direction. I organized several events on machine learning for fluid dynamics. We managed to publish a book, which was edited with several colleagues, more senior colleagues in the field, such that I could show that somehow I was also reinforcing myself on this side. I was already an assistant professor when I made this file, so I had already a team, a large team, and so also a track record of funded projects that I could, let's say, show that it was not my first project, if you want. I had already several PhD students working more or less in these areas, but again, not much into the control side, machine learning side, and that was where I wanted them to use the ERC to somehow complement my background. I applied mostly with the von Karman Institute as an hosting institution, but then also as a second hosting institution, the Université de Bruxelles, and somehow these two could provide the complementary resources, let's say, to carry out the project. So somehow the main challenges, to summarize, was the multidisciplinarity, the broad spectrum, the fact that we are targeting very different communities, from wind turbines to cryogenic systems, with the flavor of machine learning and computer science behind. And the high gain, if you want, is that we hope with this project to develop self-learning systems of energy that are very important, let's say, for the energy transition. So I will just close with a few maybe general advices, such that we leave more space for question. The first point to consider is timing. In my case, the writing process took something of the order of 5 months, but let's say the idea was already in my head since quite a bit. And the writing is obviously a very iterative process. I continuously iterate between B1, B2, B1, B2. As it was previously said, B1 and B2, they serve very different purposes. There's some kind of questions you have to keep on asking yourself. If you want, the B1 is some sort of a mixture between a TED talk, a manifesto, and a grant. So you have somehow to explain why this problem is so important. Why is it now that you have to do it, and why is it you that has the right CV to do that? Whereas in B2, you really have then to think of a stress test, like really build. Convince then more expert people that what you're proposing, in fact, is sound, and that you've been really thinking about all the problems which could go behind this. The panel, as was previously mentioned, in my case, it was very multidisciplinary. So I ended up in P8, but for some time I was even considering E6 because of the computer science and the machine learning flavor behind that. However, at the end, I ended up choosing the PA8, and I think it was a good choice. The main question to ask there is to try to think about what kind of reviewers, or what kind of panel members, I mean, what kind of knowledge you want in the people that is somehow evaluating your proposal, and so somehow has to understand and appreciate what is the main picture, even if then maybe some technical parts fall a bit outside their expertise, that there will be the reviewers for that. To what extent it's a continuation of your previous work, this is very difficult. I think this is really the art of the ERC. Somehow you have to show that your work gave you the tools, the insights, and the credibility to formulate the questions that you are formulating. So somehow it's a question which is sufficiently deep, let's say. It's that somehow you to which you arrived after having worked in the area, let's say. It's not that you have to be an expert on the topic, but if you are completely an outsider on the topic, it's harder for you to formulate a very relevant question that somehow can be, if you want, at an ERC level. So really think about the ambitions, the questions, and the methods. Why is it so? Why are you uniquely positioned? And why now? I think also the timing aspect, it's very important. Then, of course, the difficulty is to what extent it has to be high risk, but at the same time, it has to be feasible if you want. So having preliminary results is not a must-have, but it helps. Somehow you have to really you have to really show that you know what you're proposing, if you want. I don't know if there is a general rule of thumb. In my case, I was maybe trying really to think about myself, like really to be the bad guy, the bad cop, and try to think if I would be reviewing that, what kind of, I mean, would I consider this sufficiently credible, sufficiently bold, sufficiently concrete? It's not just, you have to sell it without exaggerating, of course. You need to show that you are in the field also by showing the kind of questions that you ask and the way you assess the feasibility of what you're talking about. And then the last point that I would like to mention, it is extremely demanding, also at an emotional level. I mean, it is all about you with your project, but it's really based on the PI. So there will be a lot of moments where you will feel that you're not the right person. I mean, I will wake up one day saying, I have no chance. Why am I wasting my time doing this? And other days where I would say, no, I think I can do that. So I think it is very important to manage this self-doubt. Usually, I will say that if you alternate between thinking that your idea is too bold or too crazy, maybe that you are in the right zone, I would say. Get feedback. That's something that helps me a lot. So share your ideas with a lot of people. Try to get feedback from friends and also people from outside the field. And here I will say, a lot depends on your personality, but be aware that friends can be your worst allies in this, because they tend usually to spare your feelings while reviewers will not. So criticism can be more helpful than an encouragement somehow. And if you have the enthusiasm somehow and you really believe into this project, I think you can face this criticism and use it to your advantage. Take little breaks time to time. It's nice to let it rest and then come back with a clearer mind. And anyway, I would say, regardless of whether you get it or not, the whole process, the whole stress, maybe the whole investment that you do in preparing this proposal, both for yourself and for your career, like really thinking about where are you going to be, what are you going to do in the next 5 years, and how could you get there, and so on. I mean, the whole process, I think it's really, really rewarding. And at the end of it, you get out of it stronger, clearer, more ambitious, I would say. So that is already a big win. So the only thing I can say at the end of the day is really go for it. I mean, it is hard, but it is really worth it, regardless of the outcome. So with this, I think I will close it such that maybe I can take questions.
Yes, thank you very much for your interesting presentation. Indeed, we have received a question from somebody. It's related to the panel choice. Do you know whether PE8 invited reviewers with a PE6 background, reinforcement learning? And if yes, did the interview focus on both or mainly on the PE8 parts of your proposal?
I don't know if they're invited, but I would guess yes, based on the comments. So generally, the comments which I received were all very positive, but I do remember there was one remark on whether I have sufficient background knowledge on reinforcement learning, and this was a question that was asked there at the interview. So my feeling was that somehow the questions that were asked at the interview were mostly based on the comments of the reviewer, especially quote the negative, if you want, or the most critical comments. So I did got this question on whether you have sufficient background on this on reinforcement learning.
Okay, thank you. And then we have another question. At the moment of submitting the starting grant, you have 2 journal article manuscripts submitted, but not peer-reviewed, correct?
No, I had in total maybe around 30, 40 articles, I don't even remember. So, but they were not within the scopes, I mean, with this project. So those 2 specific articles were somehow the proof of concept that this whole idea could make sense. So you can call it like preliminary or feasibility studies, and they were not yet peer reviewed. So it was not literature, it was really submitted almost at the same time as the proposal.
So the next question of this person is, how did you signal your proposal that because of these manuscripts, your proposal is more feasible because you are already on the right way? Include it in text reference in your proposal with a link to the repository where manuscript is, or another way?
Not exactly like this. So when you submit your preprint on archive, you get a code, and I just linked to that code, mentioning that this was a preprint only and that it was just freshly submitted. So it was, let's say, not past work, if you want. It was done during the process of preparing the proposal.
Okay, thanks. Then we have another one. You mentioned you had some preliminary works when you submitted preliminary papers, proof of concepts. Was this seen as a critique? For example, not sufficiently high risk?
Yes, and that was another question which I expected to receive, and I also flagged this in the presentation in the first so in the first 5 minutes of the presentation. They asked specifically these questions, so somehow I had to explain what was the intellectual gap between those preliminary results and what I actually wanted to do in the ERC. So that was absolutely a question.
And then could you give some feedback on the type of critiques that you have received during the process, also the type of questions that were asked during the interview? So
there were only 1, maybe /2 questions that got a bit more into technical details. In my case, the questions were mostly linked to the project aspects. So there was indeed one question on my lack of background in reinforcement learning. There was a question on let's say, to what extent I was actually doing novel work with respect to those 2 preliminary papers. To what extent those facilities which I were already starting to build were truly novel with respect to in what I was proposing. So they were not designed for twinning, they were designed for us to learn more about these systems, but not for the ultimate goal of the proposal. And yeah, these were the main question. Then there were 1 or 2 that were a bit more technical on how this feedback works and how it can be used.